In this lecture, we're going to talk about an attribute of polynomials, specifically of the roots of polynomials, called the multiplicity. And keeping with the general theme of this series of lectures, what we're really going to be interested in is what effect the multiplicity has on the graph of a polynomial. All right, now, so before we just start jumping into definitions, I want to look at a couple of examples that are going to help to illustrate what it is this multiplicity is doing to the graph. So what I've got here are two very similar polynomials. The first one is a linear equation. The second one is a quadratic. And what they have in common is that they both have an x-intercept at 1. So the linear equation looks like this, and our quadratic equation looks like this. So you notice their behavior at that intercept, their behaviors are very different. The language that we use here is, I would say that the linear equation crosses the axis at x equals 1. And over here with my parabola, I would say it touches the axis at x equals 1. And what really is pushing this behavior is the exponent associated with this factor. So if you look at my linear equation here, the exponent is 1, and that's an odd number. Right? When we raise a positive number to an odd exponent, we get a positive number, and you see that here. And when we raise a negative number to an odd exponent, we get a different result. We get a negative number. And that's why you see this behavior here where the graph is on opposite sides of the x-axis. Over here on the parabola side, when you square a number, it's always positive. That's why you see the graph is above the x-axis here on the left, here on the right, and above the x-axis here on the left. So to determine this crosses versus touches behavior, what we really care about is whether or not the exponent is odd or even. And it's this exponent that is what we call the multiplicity. So over here with my linear equation, I would say the root x equals 1 has a multiplicity of 1. And over here with my parabola, I would say the root x equals 1 has a multiplicity of 2. And again, what we really care about, and I'm going to summarize this on the next slide here, what we really care about is whether or not the multiplicity is odd or even. Right? If it's even, then the graph touches the x-axis at that point. And if a root has an odd multiplicity, then it crosses the x-axis at that point. All right, so let's do a quick example that illustrates this here. I have 3 factors here, right? This one, and this one. And each one gives me a different root, a different x-intercept. So the first, this x minus 1 here gives me x equals 1. The middle factor gives me an intercept x equals 3. And the first one here gives me x equals 1/2. So those are the actual roots. All right, now the multiplicity of each of these roots is just based on the exponent. The multiplicity of 1/2 is 4. The multiplicity of 3 is 2. And the multiplicity of 1, even though we don't usually explicitly write it, is just 1. And that gives me all the information that I need to talk about the behavior of the graph of the polynomial at each of those intercepts. At x equals 1/2, it touches because 4 is even. 2 is even, so it touches here as well. And 1 is odd, so it's going to pass through the x-axis at that intercept.